Okay, let's begin 3C from exam 1. We want the limit of this function. Now, if you were to plug in 4, you're going to get 0 over 0. So that's bad. What that means is that if there's going to be a limit, hopefully we can somehow factor out and divide out the two factors that are making the top and bottom 0. Now, at x equals 4, we have a problem because the absolute value function is defined as, like this. It is a piecewise function. And just notice, if you were to plug in something bigger than 4, say 5, where the absolute value sign is necessary, hopefully you say no. So that means if x is bigger than 4 or equal to 4, the absolute value signs were not necessary. However, if x is less than 4, like say 3 minus 4 is -1, so you're going to get a negative, and the absolute value signs dealt with the negative by making it positive. Well, if you were to get rid of the absolute value signs, and you were to plug in 3, you're going to get -1. Well, I need to counter that with another negative. That way, the entire function will remain positive. So this is how it's defined. So if you go back to your original function, since x is approaching 4 from the left, so that's important right there, the left, which means which version of this absolute value are we using, and it's this one. So we're going to use that instead of the absolute value function. Alright, and now you can see what happens. These x minus 4s will divide out, and you're left with the limit as x approaches 4 from the left, -1. And the limit of a constant is that constant. Okay, so just to recap real fast, when x approaches 4, that's where the absolute value function could change from one version to the other. Since we're approaching 4 from the left, which is when x is less than 4, the absolute value function is defined like this. You plug that, or you would substitute that in for the absolute value, divide out the x minus 4s, and you're taking the limit of -1, which is -1.